A compendium of image segmentation. Approaches. Abstract image segmentation is a very significant process in image processing and is widely used in tumor identification, object recognition, assisted surgeries, etc. There are a plenty of image segmentation techniques. In this paper, we present a review on algorithms used in image processing, particularly in image segmentation over the past 2 decades. Keywords: image segmentation, optimization, thresholding, snakes. Image segmentation, introduction operation in image processing and computer vision focuses on dividing the digital image into 2 or more non-overlapping segments. There are many significant approaches to accomplish the task of segmentation. Histogram-based image segmentation methods focus on classifying the image pixels based on its distribution of intensities. The peaks and valleys of the histogram assist in determining the clusters of the image. The most widely adopted image segmentation technique is thresholding. In bilevel thresholding, determination of single specific intensity value to divide the image pixels into 2 classes is done. But multi-level thresholding focuses on finding a set of threshold intensity values to classify the pixels into multiple distinct regions. While bilevel thresholding plays a significant role in extraction of background from foreground, multi-level thresholding intends to segregate many complex objects from the background. Region-growing approach to segmentation focuses on grouping pixels into regions on basis of morphological features like intensity and texture. This approach is broadly classified into 2 categories: seeded region growing, SRG, and unseeded region growing methods. Seeded region growing relies on the appropriate choice of initial seed pixels and estimation of similarity between the seed and its surrounding neighbors, usually based on the range of difference between the intensity of seed and neighbors. This approach may yield wrong results, over-segmentation, due to bad choice of initial seeds if the seed pixel is in the edge region in case of noisy images. But unseeded region growing methods commence with identification of a region comprising a single pixel and few such regions. Each pixel, neighbors of these regions but not recognized as similar pixel to these regions, are tested by computing the difference in intensity between the unallocated pixel and the mean intensity of the current regions. The unallocated pixel that has the minimum intensity difference with any of these regions and with intensity not exceeding the predefined threshold T is selected as a pixel belonging to that corresponding region. The process is repeated until all unallocated pixels fall into some region. It is evident that the results of SRG vary based on the order of processing the pixels. To improve seeded region growing algorithm, several approaches like scan order optimization, automatic seed selection and temporal seed tracking may be adopted. 22. Existing literature on unseeded region growing reveals that the initial region does not influence the results of segmentation. Region splitting and merging is familiar region growing method consisting of 2 major approaches: region splitting, a top-down approach to divide image into many dissimilar parts, and region merging, a bottom-up approach to combine similar results at each stage of region splitting. Edge-based image segmentation methods focus on identifying discontinuities in the image. Usually, Roberts, Pruitt's, Sobel and Canny edge operators are employed in such deductions. Active contour models, ACMs, or snakes help in identification of the contours of the object on basis of internal energy that prevents deformation and external energy that fits the contour into the image boundaries. The basic classification of image segmentation technique has been presented in Figure 1. Histogram. Clustering. Entropy. Object attribute. Spatial methods. Local methods. Edge-based active contour model. Pruitt, Sobel, Roberts, Canny. Figure 1. Image segmentation approaches. Classification. Thresholding-based segmentation. Image thresholding 10 can be done using one of the following methods. 1. Histogram shape-based, the peaks and valleys of the smoothed histogram are analyzed. 2. Clustering-based, gray level samples are grouped together as foreground and background or modeled as a mixture of 2 Gaussians. 3. Entropy-based, optimization of the entropy of foreground and background regions is done. 4. Object attribute-based, similarity between binarized and gray images is estimated. 5. Spatial methods, correlation between pixels is focused. 6. Local methods, different threshold values are selected for every pixel of the image. Thresholding can be applied either locally or globally. Different threshold may be applied to every part of the image in local thresholding, whereas a single threshold value is estimated in global thresholding. To find a suitable threshold intensity of an image, either a parametric or non-parametric approach may be adopted. While the former deals with determination of statistical parameters with greater computational expense, the latter selectively chooses optimal intensity values by maximizing certain constraints. Generally, the two regions estimated using bi-level thresholding is stated as where and are two regions of image F with pixels ranging in the interval 0L, classified based on threshold T. Likewise, the regions estimated using multi-level thresholding can be stated as one such well-known thresholding method is its thresholding technique, wherein the between-class variance is maximized or intra-class variance is minimized. If bi-level thresholding needs to be performed, then the objective function is stated as where and are the weights of the two classes, and represent the variances of those classes and indicate the mean of those classes. This maximization or minimization can be done using adaptive bacterial foraging algorithm 16. Since image segmentation focuses on maximizing the dissimilarity of pixels belonging to different regions and minimizing the dissimilarity of pixels of the same region, entropy, a measure of randomness in the region, is adopted for the task of image segmentation naturally. In case of bi-level thresholding, the objective function of Capper's entropy criterion 8 can be formulated as where is the probability of occurrence of each gray level I, T, L, and N indicate the threshold intensity value, total number of gray levels and total number of pixels in the image respectively. If multi-level thresholding needs to be performed, the objective function is reformulated as where indicate the threshold intensity values. Since 8 focuses on identifying facial regions of an image, IHLS, intensity hue luminance saturation color space, is used to distinguish regions comprising human skin. This conversion of RGB, red, green, and blue color model, to IHLS color space is given by in 8, Capper's entropy is maximized using bacterial foraging optimization. Likewise, the objective function of Capper's entropy criterion for bi-level thresholding is formulated as given below, where T, S, Q, and L represent the threshold intensity, Capper's entropy, anthropic index indicating the degree of non-extensitivity of a system, and total number of gray levels respectively. 12 employs harmonic search algorithm, a meta-heuristic approach known for its searching efficiency and simplicity to determine multiple threshold levels that maximize Capper's entropy. Such kind of optimization of Capper's entropy is implemented using cuckoo search algorithm 13, particle swarm optimization 14, and artificial bee colony 15. 2. Edge-based segmentation. Edges are discontinuities of an image that can be estimated using certain operators. The widely used operators include Edison, Rothwell, Susan, Roberts, Pruitt, Sobel, and Canny 23. Of all the operators, Canny edge detection is superior since it can recognize edges of different characteristics. It detects spurious edges and detects potential edges. Detection of edges can be done by applying the foraging behavior of E. coli bacteria as in bacterial foraging optimization. 23 focuses on driving bacteria through edge pixels by moving in a direction determined using direction probability matrix developed from transition probability matrix, a function of heuristic factor and amount of pheromone discharged by ants on the path in ant colony optimization. 3. Active contour models. Active contours are methods which commence with initial boundary shapes in the structure of curves that shrink or expand based on the image constraints. These shrink and expand operations are termed contour evolution, that includes optimization of energy functions or simulation of partial differential equations, PDE, 21. Mathematically speaking, these active contours may be categorized as snakes and level sets. Broken edges can be connected to frame a perfect edge by utilizing Hoff transform 17 or by application of ant colony optimization 18 or bacterial foraging optimization 19. In 20, it is attempted to classify mammographic images as benign or malignant using artificial neural network, N. Thresholds are computed using N and seeded region. Growing is performed. Feature extraction is done using genetic algorithm. Also, an alternative method for automated image segmentation is suggested, wherein templates may be produced from mammographic images using and segmentation may be performed based on these templates using cellular neural networks, CNN. Table 1 Summary of segmentation techniques. Type of segmentation approach literature. Thresholding based 8, 10, 12, 13, 14, 15, 16. Edge based 23. Active contour model 17, 18, 19, 20, 21. 4. Discussion. The segmentation techniques discussed in this paper has been summarized in Table 1. It can be seen widely in thresholding techniques that optimization algorithms have been implemented for improving the results. Such optimization algorithms have also been tabulated in Table 2. Neural networks were also employed in active contour models. Conclusion. In this paper, summary on the widely used techniques for image segmentation used over the past 2 decades was presented. The algorithms discussed here are mostly a combination of image processing approaches and optimization algorithms. In future, more segmentation techniques will be taken into account and wide comparisons even with respect to the tuning parameters in optimization will also be considered. And a broad analysis with respect to the applications in the literature will also be done. Apart from these trends, there are many topics including new research involving deep learning.